Good afternoon, everyone. So today we are going to discuss paper 2 of the full course test series. Now, in this paper we have 20 integer type questions. Now, you might think since these are integer type, that means these will be objective questions. But the integer type that do comes in mains and advanced paper, they're actually disguised subjective problems in itself. That means these are only objective in appearance, but in their working they will be subjective in nature. That means you have to work it out. That means you have to do the steps. But mind it, you have to do the necessary steps. Obviously, in these kind of questions, you will not say, let the mean of the numbers be x bar. No, you will not do that. But those essential steps that you have to write, you have to write them. You cannot skip them. If you try to look for a shortcut in each and every question, there might be an error over there, or you might be just wasting your time. When the question has a technique attached to it, and you know it is a little bit lengthier technique, you might just have to do it instead of looking for the shortcut method. Right? So these are nothing but disguised subjective problems in itself. Alright? So without further ado, let's begin with the very first question. Now he says if mean deviation of numbers 2, 2 plus d, 2 plus 2d, 2 plus 3d, so on till 2 plus 90 from their mean is 250, then write the value of d. Right? So mean deviation of all these numbers from their mean is 250. Now if I look at the numbers, I can say this is an easy. In fact, if I look at these numbers 2, 2 plus d, 2 plus 2d and so on 2 plus 99d. Every number has the term 2 in it, right? Why do I bother with 2 in this case anyway? Since I want mean deviation from the mean, why can't I just find the mean deviation of these observations? 2, let it be 0, and then I will say 1d, so just d, then 2d, and so on till 99d. And in order to make it more pretty, I can just say this is nothing but 0 instead. Right? Now you'll say what happened to the 2. Mind it, since I just want the mean deviation, let's remember the formula for mean deviation. That was mod of xi minus x bar divided by a number of observations. Right? If I'm adding 2 to each observation, the mean will also be added by 2. Right? But the difference, adding 2, the difference will make sure that the addition of 2 to each observation does not have any impact in the mean deviation from the mean. Right? Since 2 does not, adding of 2 to each observation does not make any impact, so let me just get rid of it. Might make my calculation easier, right? Okay. So instead of finding out the mean deviation of this, I will find out the mean deviation of this. Since I know the mean deviation for both the sets of numbers are the same, right? So let me have the mean deviation, but from their mean, that means I need to find the mean first. So I need to add all of these numbers. So I can see, I can take b common out. Right, 0, I will not write it again. So 1 plus 2 plus so on till 99. Right, whole divided by number of terms. Mind it, number of terms is 100. Right, so this is d into 99 into 100 by 2 and 100 100. Right, so the mean turns out to be 99d by 2. Right, so I know my x bar over here. Now I want the mean deviation from each observation. So let me start. 99 by 2, I will take it from the first. So this minus this, obviously the mean deviation is nothing but 99 by 2. And then this, in fact I should say this minus this, but absolute value so really doesn't matter, but still. This minus this, so I will get 97 by 2. The next will be 99 by 2 and so on and on. Mind it, if I proceed further like this, I will get d by 2. Right? This is for the first 50 observations from here, first 50 observations. Then when we come to the next 50, again the deviation will start like this. It will get d by 2, then it will get 3d by 2, and so on. I will go on till 99d again, 99d by 2 again. You can see that all of these observations, all of these deviations will repeat again. So I will not try to write it. I will just double this up. Mean deviations. Right? Obviously, I will divide by the number of observations. Don't worry about that. So I can take d by 2 common, and 2 is already here. Then I have, if I write it like that, so 1 plus 3 plus so on plus 99. right? Whole divided by number of observations, which is obviously 100 in number. 100 observations, so 100 mean deviation is equal to 250. Right? This I already know. This is sum of first 50 odd natural numbers, that would be 50 square. You can easily find the value of t, which will turn out to be 10 in this case, which is the answer. On to the next question. Now he says that alpha be the distance between parallel tangents of the cylinder, which have a slope -1. Then write the value of alpha square. Right? Basically, I am interested in finding the distance between parallel tangents to the cylinder. But it has a condition that these two parallel tangents have a slope -1. Right? Now, if the slope of the tangent is -1, that means I will be using the equation of tangent as y is equal to slope is -1, so -x plus c. Right? I'll use the fact that the slope is -1. Now, I know that this line is tangent to the ellipse. If this line is tangent to the ellipse, by simultaneously solve it, the discriminant should be equal to 0. Why? Because I want the constant roots. That is how I will make this line tangent to this ellipse. Right? So, if I simultaneously solve it, I will get my discriminant as c square plus 2c minus 35. I will leave that part up to you. And from here, we get two values of c, which is -7 and 5. Right? So, two tangents crop up over here. Y is equal to -x minus 7. Y is equal to -x plus 5. Parallel line, right? You can write it properly. You can do x plus y plus 7 equal to 0, and then x plus y minus 5 equal to 0. Apply the formula for the distance between parallel lines, which was mod of c1 minus c2 divided by, here I have nice ones only, so divided by 1 root of 1 plus n square. Just use that, you will get the answer as 72. Alpha square turns out to be 72. Alright. Now it says three positive numbers form a decreasing GP. Mind it, decreasing GP. So that means the term will decrease, of course. Now it says the middle term in this GP is triple. The new numbers are in AB. Okay. And the common ratio is A plus 0. Then write the value of this. Right? So basically, if I'm able to find the common ratio, I can evaluate this. All I'm interested in is the common ratio of this GP. Now he says three positive numbers. Let those three positive numbers be A, AR, AR square. Also, it is a decreasing GP, mind. Now when I say decreasing GP, I have made sure that the common ratio over here is less than 1. Is that okay? Okay. And positive numbers is there, so obviously the common ratio lies between 0 and 1. Cool. Now, he says the middle term in this GP, that means this one, is triple. If this term is triple, so my new series becomes A, 3AR, and then AR. Right? Now, this sequence he says is AP. Now, AP, that means this minus this is equal to this minus this. Or I can say twice of this, 6AR is equal to A plus AR. Right? Now, obviously, I can cancel out A since this is a non-zero quantity because this is a GP. So, A has to be non-zero. So, that means I'll get a quadratic in R, which is 6R square minus 6R plus 1 equal to 0. From here, you will get two values of R. You will get R as 3 plus minus 2 root 2. Now, mind it, I want that R which is less than 1. Right? Obviously, R in this case will be 3 minus 2 root 2. That means A is 3, B is minus 2. Minus 2, yeah. Just substitute it and you will get the answer as 13. On to the next one. Now, he says in how many ways can 4 zeros be arranged? How many zeros? 4 zeros be arranged in these 9 squares, as you can see, so that no row remains empty and no two adjacent squares in a row have 0. Now, no row remain empty. That means something should be here, something should be here, something should be here. Obviously, this is a row, this is a row, this is a row. Hoping that you know what a row is. Okay. Then he says no two adjacent squares in a row have 0. So that means if I'm putting the 0 over here, I cannot put 0 over here. I have to put it here. Right? So, adjacent but in a row. Right? Okay. So, makes sense. Now, it says in how many ways can I put 4 zeros over here? Right? I'm interested in putting in these 4 zeros. Now, what I can do is, since I have to make sure that no row remains empty, So let me see how many zeros in each row I can put. Right? Now let's talk about the first one. Obviously, since just two boxes are there, I have to put in one at least, right? So let me start with one. 1 0 over here in this row, 1 0 in this row, and then in total 4 zeros, right? So that means remaining 2 I have to put it over here. I'm just writing down the cases how I have to arrange. I will do that. Cool. Or next case might be I will put 1 over here, right? Then instead of 1 I can put 2 over here. 3 zeros accommodated. Then just 1 0 I have to put that over here. Done. Right? Next, I can't do 1 3 because then I will not have any zero to put in the last. So case is exhausted. So one case is exhausted. Like it starts with 1. Now the question is, can I have more cases? Now, do you think in this can I put 1? Can I put 2? Absolutely no. I cannot do that. What else? So just 2 cases basically. Right. So let me take this case. That means 1 0 I'm putting over here, 1 0 I'm putting over here, and 2 zeros I'm putting over here. In how many ways can I do that? 1 0 over here, right? So either I can put it here or here. So basically 2 possibilities. Right? Okay. Let's come to this one. 1 0 in this row. Either I can put it here or here or here. So that means 3 possibilities. Right? Now corresponding to each choice over here, I have 3 choices, right? So that is why I will multiply it. Cool. Let's come to this one. Now I have to accumulate 2 zeros over here. And how many ways can I do that? So I can put, obviously let's start with this one. 1 here. Then I cannot put it here, the other 0 have to be here. One way. Then second way is instead of putting over here, I can put my 0 over here. Right? Another way. Now third way. This thing I've exhausted, so let me just move the zeros from here. So if I put my 0 over here, the next 0 that I can put, that is right? So in total, the number of ways of putting in 2 zeros in this row is 3. Now corresponding to these choices, I am getting 3 choices in the last one. So that is why into 3. Right? So that means if I take this setup, I am getting these many arrangements. Cool? So this is the first one. Second. Now again, he says you need to put 1 0 in this. I have 2 options, either this or this. So 2. Corresponding to this, let me talk about this row. Now I have to put in 2. Now, how can I do that? Now, if I start with here, I have to put it here. Just 1 minute. Okay. Right? If I put my 0 over here, do you think I will have any other choice? Absolutely not. So that means for this one, if I need to put 2 zeros in this row, I just have 1 zero. So into. Now, here I need to put just 1 0 in this row. Either this one or this one or this one or this one. So in total, I have 4 choices. So into 4. Right? This is nothing but 18. This is 8. In total, I am getting how many ways? 26 ways. Alright. On to the next one. Now he says, let K be the solution for this equation. Write the absolute value of 20 times the sum of all real values of K. So in total, I need to find the solution of this equation. Right? Now, this looks scary, but if I look carefully, here I have 3x plus 2, and then I have 7x plus 3. And then I have this polynomial, 21x squared plus 23x plus 6. I can see that this polynomial is nothing but this into this. Now, that can't be a coincidence, right? Right? So, let me just write it like this. So, log of, I will write this as 3x plus 2 into 7x plus 3 to the base 3x plus 2. Observation number 1 is equal to 4 minus log of, now base I am writing 7x plus 3. Now this is nothing but 3x plus 2 whole square, right? 3x plus 2 whole square. Done? Right? Now I now know that log of AB is equal to log of A plus log of B. I will do that. So log of 3x plus 2 to the base 3x plus 2, that is 1, plus log of 7x plus 3 to the base 3x plus 2 is equal to 4 minus. First of all, this 2 is here. I will write the 2 here. So 2 into log of 3x plus 2 to the base 7x plus 3. Now look at this term and look at this term. Obviously, these two terms are related. So put this as c and that will be 1 by d. So I will get 1 plus c is equal to 4 minus 2 by d. Right? If you cross multiply, take the LCM, blah blah blah, you will get the equation as t square minus 3t plus 2 is equal to 0. Such a nice pretty quadratic equation, and we get t equal to 1 or 2. Right? Now t equal to 1, that means log of, because I put this as t, right? Log of 7x plus 3 to the base 3x plus 2 is equal to 1. From here, obviously you can solve it. X turns out to be minus 1 by 4. Right? Okay. And for the second one, log of 7x plus 3 to the base 3x plus 2. This is equal to 2. From here, you will not get any real root. So I do not care. Right? Now, I just get one real solution. Now, the thing is, ideally, I will put these here and check whether my domain is satisfied or not. But the question is there, right? And that's the only solution. I do not need to check it. Otherwise, my question will be wrong. Right? So, I will just get my k, which is minus 1 by 4. Then I will do absolute value of the 20 times. That means the answer will turn out to be 0. Alright, on to the next one. Now he says let f of x equal to this when x is greater than 2 and equal to this when x is less than 2. I have written it like this because I needed the space beneath it. Alright, then he says if limit x approaches 2 minus is alpha and x approaches 2 plus is beta, then write the value of x. Basically, I need to evaluate these two limits as x approaches 2 plus and as x approaches 2 minus. Right? So, I'm interested in finding out the limit of this function. Clearly, it is 0 by 0 form. Right? So, that means I need to find out that common factor and cancel it out. But radical sign is getting involved. Now, whenever radical sign gets involved, we need to rationalize it. But mind it, we have 4, 1 by 4. Right? So, we have to rationalize twice. But it's okay. We know what to do. Right? So, rationalizing factor. So, x by raised to asterisk into. Now, I know because I will want to square it up, my rationalizing factor would be 4th root of 3x plus 10 plus 4th root of 5x plus 10. Right? And denominator also I will write it down. Alright. Now, mind it, when I do this term, which I will not write it again, this term into this term, a minus b into a plus b, right? I will do that. And basically, I will get square root of 3x plus 10 minus square root of 5x plus 10. I have to rationalize it again. So, that means my rationalizing factor in this case would be square root of 3x plus 10 plus square root of 5x plus 10. Right? And I will write this factor again over here. I will not write it again. Right? So, a minus b into a plus b will become a square minus b square again. So, in short, I will get this thing. I will get in the numerator 3x plus 10 minus 5x plus 10. Right? Which is nothing but minus 2x plus. Right? I can take minus 2 common. So, I will get minus 2 into x minus 2 divide by x minus 2 and this quantity again. Right? You have cancelled out that factor which was making it 0. Now limit can be evaluated. Limit of numerator obviously is minus 2 and limit of denominator you can easily find out. Right? Okay. And alpha actually turns out to be, actually this is beta. Yeah, beta actually turns out to be minus 1 by 16. Alright, let's come to this limit. Now, this limit is very easy. Now, x square minus x minus 2. This exact term has to be there, right? Because I remember the limit of x approaches 0 of e raised by x minus 1 divided by x. Right? Whatever here, it has to be here. So, I want x square minus x minus 2 in the denominator. So, obviously, I will multiply by x plus 1. Right? And obviously I need to divide it. So here I will accommodate x plus 1. Right? Now this limit I can evaluate and from here I will get my alpha to be 3. Just substitute it and you will get the answer as 0. Alright, the next one. Now he says the set of lines are concurrent where this condition is satisfied. Let h comma k be the point of concurrency, then we need to find the value of this. Basically, I need to find the point of concurrency. Now, he says for all of these lines, there have to be some point of concurrency. That means all of these lines must pass through a fixed point, right? And that fixed point, he says, that is h comma k. All of these lines, as in this family of lines passes through this, right? That means I am interested in a certain value of x coordinate and a certain value of y coordinate, which will make this quantity equal to 0 no matter what a, b, c is. But there is a condition on a, b, c, right? Now there is a condition on a, b, c. 3a minus 2b minus 4b. This I need to use. This I need to use. First of all, this similar quantity I would want to generate it over here, right? Now, mind it, I can put the values of x and y, right? This c will not have any consequence on it. So, with the condition that I have minus 4, right? Here I do not have minus 4. So, what I'll try to do is, I will try to generate minus 4 over here, right? So, minus 4c if I want, multiply by minus 4. Because it doesn't matter, I can multiply by any number that I want. So, this is minus 4ax minus 4by minus 4c equal to 0. Now, looking at these two, you need to think of some value of x and y which will make this term equal to 0. Right? This term is already equal to 0. If I am able to create this over here, I will make sure the left hand side is equal to 0. How do I make sure? If this 3 is equal to minus 4x, that means if x is equal to minus 3 by 4, and at the same time, this minus 2 is equal to, and minus 2 is equal to minus 4y. So, y is equal to 1 by 2. Right? Now, if I have the point minus 3 by 4, comma 1 by 2, if I have this point, that means x is minus 3 by 4, y is 1 by 2. If I put this over here, this term will get changed. This expression will get changed to this. And I know the value of this expression to be 0. So that means this point that you got, that is the point of concurrency. No matter what a, b, c is, if I put my x and y this will change into this and this is equal to 0. That means this point satisfies this equation. Right? So this is my point of concurrency. This is point of the concurrency, that means this is h, this is k. Just substitute it and you will get the answer as 0. Alright, on to the next one. Now he says let a comma b be at a unit distance from each of these lines, L1 and L2. If a comma b lies below the lines L1 and L2, then write the value of this. Right? Now write the value of this. Basically I want a comma b. Basically I want this. Now there are two conditions. Now he says that this point is at a unit distance from this line as well as this line. Right? The distance between this line and this point and this line is unit, which is 1. So I know the formula. So that is mod of 3a minus 4b plus 14 whole divided by square root of this square plus this square. So that is 5 equal to 1. So I will cross multiply. I will just write it as equal to 5. Right? The second one, similarly, mod of 4x plus 3y plus 2 whole divided by, again, 5 is equal to 1. So I will write is equal to 5. Right? So I have used this part of the question. Now he says that this point lies below the line L1 and L2. Mind it, because if I need to solve these two, I need to talk about this absolute value sign. Right? What do I do with this? This condition will help me. Lies below. Now the question is lies above the line, below the line. That I can see from the graph, from the diagram. So let me make tentative diagram. Right? So let me have my line 1. There is line 1 here. So the x-intercept is minus 14 by 3. So maybe here. Tentatively I said. And this is 14 by 4. So 7 by 2. So maybe here. Exaggerated it, but it's okay. So this is my line L1. Now he says a comma b lies below it. So this side. If it is this side, then I need to talk about this absolute value sign. Right? You can take any point on this side. Which point do we like the most? 0, 0. Right? If a comma b is on this side, that means a comma b and 0 comma 0 will satisfy the same equal. It will satisfy the same sign, right? So let me see what 0 comma 0 satisfies that. If I have my line 3x minus 4y plus 14 equal to 0. 0 comma 0 satisfies the positive one, right? The positive sign. Now a comma b is also on the same side, so that means it will also satisfy the positive sign. So that means this mod will open with positive. Alright. Now the next one. Now he says it lies below L2 also. So let me make L2 tentatively. So he says L2. X-intercept is minus 1 by 2. So maybe here. Tentatively I'm saying. Right. And y is minus 2 by 3. So maybe it is here. Tentatively. Cool. So my line L2 is here. Now he says it is below. Right. So that means it will be this side now. A comma B will be this side. Right. Now I need to talk about L2. Right. Now mind it, 0 comma 0 and A comma B, they are on the opposite side. So whatever sign this satisfies, 0 comma 0, A comma B will satisfy the opposite one. So let me check. What does 0 comma 0 do to the second one? Second line is 4x plus dy plus 2 equal to 0. And 0 comma 0 will obviously be positive. If 0 comma 0 is positive, that means A comma B will have the negative sign. If it has a negative sign, that means the mod will open with a negative sign. Right here, I should have written A and B, by the way. You get that one. Right? Now you have two linear equations, you can solve it. B turns out to be 3 by 5. And A comes out to be minus 11 by 5. That is why the answer is 24. Alright, on to the next one. Now he says there are 3 APs with their first term equal to 55, 57, 59 respectively. So 3 APs, first AP, first term is this, second AP, first term is this, third AP, first term is this. And he says their common difference are 3, 5, 7 respectively. So first common difference is 3, so next term would be 58, then 61, so on. Then 55, then 5 it is, so plus 5, 62, then 67 and so on. Then the common difference is 7. So this is 66, right? Oh, 66 plus 7. So that is 73 and so on. Right? Now he says the common terms of the 3 APs. The common terms. That means I will find some common term over here, some common term over here, and some term over here. And it will be common to the 3 APs. The term I'll find in all these 3 will be common. He says then those common terms form another AP whose first term is this and common difference is this. You need to write the value of A minus A. Basically, you need to find the AP of the common term. Right? Now, if I want to find the AP of the common term, I need the first term and common difference. Common difference is very easy to find out. Why? I know here the jump is of 3. Here the jump is of 5. And here the jump is of 7. For the common term AP, the jump has to coincide with the 3 jump of 5 and jump of 7. This will only happen when we have the jump of 105. Does that make sense to you? That means common difference is 6, that is 105. All I need to do is find out the first term. Now, the problem with this question is, I write my first term still. Suppose I've written the first term till 100, right? And this I have written till 102, and this I have written till this is 70. 3. So maybe it comes up to be 98 plus 101 maybe. I don't know whether it does come or not. We'll have to check it out. Right? Now the question is 100, 102, 101. Till here I have not found any common term. Right? Obvious thing is you keep on writing. But after a certain time, it gets very irritating to write these terms. Right? Because then you're like, oh, did I miss something? Did I lose something? Because I'm still writing and still there is no common term. For the first term, we need to do that. But the question is, instead of writing all these 3, I will just write this AP. Right? Because here the jump is maximum, the jump is of 7. Right? So I can keep on writing this AP, right? And so on. I will move on to 108 and write it down. Now the question is, what I can do is, I will write, suppose I've written 108. I need to check whether 108 is present in this AP or is it present in this AP. For that, it is very easy. Look, this is an AP. Jump of 3 is occurring, right? Jump of 3 is occurring. That means I can see the form of all of these numbers. It is nothing but 3k plus 1 form. Right? And if I look at the number and I am able to ascertain whether it is of the form 3k plus 1 or not, my job is done. If it is of the form 3k plus 1, it will be in the AP. If it is not, then it will not be. Right? I just need to check the form of the number. Similarly for this one, I can see the jump is of 5. This is all of those numbers which have the form 5k plus 2. Right? So just this I need to check whether this number is of the form 5k plus 2 or not. If it is, it will be in the AP. If it is not, it will not. Right? This you need to keep on checking up. You will just write the terms for this AP and check whether the number is of the form 3k plus 1. And it should also be of the form 3k plus 2 simultaneously. Because I want the common terms for the 3 AP. If it is that the case, then you will have your first common term. And the first common term that comes out in this case is that is 157. Right? Obviously, we know A, we know D. The correct answer in this question is D2. Alright. On to the next one. Now he says a card is drawn from a pack of 52 cards. If P be the probability of getting a face card, or a heart, or a red card, then write the value of 39. So basically, I need to find the probability that either a card is face card, or heart, or red card. Right? So maybe my event is, let me consider this as the event E, this my event F, and this my event G. Now it is an objective paper, so no need to write let E be the event of getting the face card. Don't do that. Just write it in the question or in your mind, whatever works for you. That means that I am interested in probability of E union F union G. For this I know the formula probability of P plus probability of F plus probability of G. Okay, do I need to write everything? Okay. Minus probability of E intersection F minus probability of F intersection G minus probability of G intersection E, then plus probability of E intersection F intersection G. I will not write the formula because you already know that. Right? Now, let me just evaluate all of these very quickly. These are very simple to evaluate, by the way. Probability of E, that means getting a face card. How many face cards are there? 3 cards, face cards in each suit. 4 are there, so that means 12 face cards. So 12 by 52 plus probability of F, heart, 13 by 52. Okay. Then probability of red card, that is 26 by 50. Minus E intersection F, this intersection this. So that means face card and a heart, so that is 3 by 52. Then minus F intersection G, so heart and red. So obviously just heart. So 13 by 52 minus red and face card. So that is 6, right? Because diamond and red, both of them. So 6 by 52 plus all of these face card, heart, red. So basically that is heart and red, heart and face card. So that is 3 by 52. Just evaluate it. You will get this as 32 by 52. Substitute it and you will get the answer as 24. Alright, on to the next one. Now he says write the number of rational terms in this expansion. Clearly I can see we have 3 terms over here, right? So that means I need to consider 2 terms as a single term and then open it up. So the question is, which 2 terms will I take as a single term? Mind it, I would want my number of cases to be less, right? Now, if I take this as a lonely term and these 2 as my single term, that means here I will have to take it to be raised by 30, raised by 28, raised by 26. That means there will be too many cases that I need to study. If I take this one, then raised by 30, cool. Then raised by 27 I would like, then 24 I would like. So a little bit less number than this one. But if I take this as my lonely term, that means raised by 30, then raised by 25, raised by 20 and so on. That means in this case I am getting the minimum number of cases. So I will keep this as my lonely term and these 2 I will combine together. Right? So this, let me write it down like this. So fifth root of 5, and this is root 2 plus cube root of 3. Right? This I need to open up. Now I will not write the binomial coefficients. Why? Because I just need the rational term, number of rational terms. If I take the first one, this becomes root 2 plus cube root of 3 raised to power 30, and here it will be power 0, so I will not write it. Now if I try to open this up, now again I need to see how many rational terms I'll get from here. Right? If I open this up, the first term that I'll get, that will be root 2 raised to power 30 into this thing raised to power 0, so I will not get anything. So that means I'm getting the first rational term. Right? Second rational thing, if I need to check, that this will be 28, but this will be 2 raised to power 0, not a rational term. Then this will be 26, this will be raised to power 4, not a rational term. Right? In fact, from this I will just get only 1. Right? Now, second thing, then I need to consider is, now if it is raised to power 5, that means this will be raised to power 25. So root 2 plus cube root of 3 raised to power 25. Right? And this also you need to exhaust it. If I take this raised to power 25, it is not a rational term. This raised to power then 24, but this is cube raised to power 1, so cube root is there. Then this raised to power 23 will not work, 22 it will work, and if this is raised to power 22 and this is raised to power 3, then I will get my rational term. Right? Now the problem is, if I do it like this, there is a probability that I will actually miss out something. That is the problem. What I can do is, I can make use of my general term. Here, if I need to write my general term, it will be what? 30 CR into 2 raised to power 30 minus R by 2 into 3 raised to power R by 3. I have to make sure that this, from here also I get rational term, from here also I will get a rational term. That means, from here I should get some natural number, or maybe a whole number for that matter. That means I will check for R is equal to 0, 3, 6, so on, and then I will see corresponding to this whether I am getting that or not. In that way, if I study, there is a less probability of losing of something. Right? Similarly, here also, just write the general term. I will get 25. I don't need to write the binomial question, nobody cares. So 2 raised to power 25 minus R by 2 into 3 raised to power R by 2. Now I have to make sure that this is also a whole number, this is also a whole number. So again I will check for R is equal to 0, 3, 6, 9, and at the same time I have to make sure that this is also a natural number or a whole number. Right? In this way I will calculate it. You have to calculate it and you have to do the technique, which is this one, and ultimately the answer will turn out to be 21. Okay. Alright, on to the next one. Now he says my function f of n is defined like this. It is 1 by 4 plus 3n by 100, and this function is obviously the greatest integer less than or equal to n. Basically the greatest integer function. Right? Now he says if summation n varies from 1 to 35 is equal to alpha, then write the sum of all digits of alpha. Basically I need to add all of these terms when n varies from 1 to 35. Right? Mind it, I need to write all of these terms, right? And I need to multiply this term by n. Okay, I'll do that. Now, this is the greatest integer less than or equal to n, or this number. How should I proceed? Now, if I put, and let me talk about f of 1 first. So, this is 1 by 4 plus 3 into 1 by 2 into 1. Mind it, 1 by 4 plus this number. Definitely this number is less than 1. So, greatest integer, this thing will become 0. 0 into 1, that is 0. If I write f of 2, again the same problem, it is 0. The thing is, all of these will be zeros till the time I make sure that the quantity inside this is either equal to 1 or greater than 1. Then only my numbers will start increasing. Otherwise, this will become 0 multiplied by some natural number, it will be 0. Now, the question is, if I want to make 1 by 4 plus 3n by 100 and be equal to at least 1, right? So, 1 by 4. In addition, that means this should be 3 by 4. That means this 3 is already here. This n by 100 thing, this should be at least 1 by 4, right? At least 1 by 4. So, that means n should be at least what? N should be at least 25. Now, if n is at least 25, that means I will not care about f of 1, f of 2, f of 3, because I need to add them up at the end, right? 0 plus 0, 0, I do not care. So I will write my first term as f of 25. Right? Actually it becomes, now this quantity exactly becomes inside 1 into 25. So this is 25. Then f of 26, now it is slightly greater than 1, right? So this thing is 1 only into 26 and so on. Now the thing is, let me check what happens for f of 35. Whether this quantity inside becomes equal to 2 or not, or maybe greater than 2. Actually it doesn't. Again the quantity is 1 point something, so that means this is 1 into 35. It is 35. All is he asking you is to add these numbers. This is an AP. You can definitely find the sum of this. If you add these up, it is 330, which is alpha. But he says write the sum of all digits. That is why the answer is 0, 6 in this case. Alright, on to the next one. Now, he has given us a big ass question, right? It's okay. We'll start step by step. Now, he says a particle P starts from Z0, 2 plus iota. It moves horizontally away from the origin by 5 units. Now the thing is, he is talking about the movement of the particle and he has given the movement in terms of the complex number, right? So let me make my origin plane, it will be easier to visualize, right? So my origin plane is something like this, 2 plus iota. So that means initially my particle is here, P is here, right? It moves, so let me write this as 2 plus iota, right? It moves horizontally. Obviously horizontal means like this. Now, he says away from the origin. If I go this direction, obviously it is towards the origin. Origin is here, right? So, horizontally away, so that means he is going in this direction by 5 units. So, this is 5 units and this is the new position. Now, if this is 5, that means I can write the complex number representing this. So, which is 7 plus iota, right? Then moves vertically away from origin. Now, vertically that means he will go in this direction, but away, so that means in this direction by 3 units to reach Z1. So, 3 units. So this point is 7 plus 4 iota. So this is Z1. Now he says from Z1 it moves root 2 units in the direction parallel to y is equal to x. Now he says direction parallel to y is equal to x. So that means it moves at an angle of 45 degrees. Cool. So that means it will move like this now. 45 degrees minus this is 45 degrees. And this distance is root 2. Right? Increases here. Mind it, if this is 45, this is root 2, this length has to be 1 and this length has to be 1. So that means the new coordinates will be 8 plus 5 iota. Right? So my point has reached up to that point. Then he says, then move through an angle of 90 degrees in clockwise direction. Okay, it is going to move through an angle of 90 degrees in clockwise direction on a circle with center O. So my point is here. Right? Now he says, I need to make a circle with center O, so I'm just going to join them. I do not know where it intersects or not. It's just tentatively, I do not care. So here it is. Cool. So on a circle it will move. So that means it will go like this. So whatever this distance, it will be this distance itself. Now clockwise, obviously, it will go like this only. Through an angle of 90 degrees. Through an angle of 90 degrees. So that means this will be somewhat here. Cool. This is 90 degrees. Then he says, this is my Z2, you need to talk about the coordinate, the complex number. Cool. Now I know rotation through 90 degree in clockwise direction will make the complex number multiply by minus iota. Right? We know that basically iota is my rotator. In clockwise direction, it is minus iota. Obviously in anti-clockwise sense, you can see. Right? So multiply this number by minus iota. So this becomes minus 8 iota minus 5 iota square. So plus 5. Right? So my number is 5 minus 8 iota. Right? You know A, you know B. That means you can find the answer as 18. Alright. On to the next one. Now he says let A and B be points in space. Alright. So A is here, B is here. And we know the coordinates also. Now he says, let C be a point on AB and divides it in the ratio 3:2. Right? So C is here maybe and this ratio is 3:2. Now if this ratio is 3:2, I can easily find out the coordinates of C using section formula. right? You can apply that 3 into 6 plus 2 into 1 divided by 5. That will give you the x coordinate. Similarly, y coordinate, similarly z coordinate. C will actually turn out to be 4, 2, minus 1. Now he says if distance of C from the yz plane, right? Now distance from yz plane is nothing but the x coordinate, which is 4. Nothing to write. And then he says from x-axis, distance of the point from x-axis is nothing but square root of 2 square plus minus 1 square. Can you see that? This is nothing but beta. You know alpha, you know beta. You can find out the value of this, which turns out to be 0, 9. Alright. On to the next one. Now he says write the total number of numbers between 1000 and 10,000. Any number between 1000 and 10,000 will be what? A 4-digit number? 1, 2, 3, 4. Right? Now he says you have to use these digits. 1, 2, 3, 4, 5. So that means out of these 5, you need to choose 4 in order to have your number. Right? Now he says the repetition is not allowed and the number is either divisible by 3 or by 5. Right? Either 3 or by 5. So let me have the number which are divisible by 3 first. Right. Then I will take number divisible by 5. And then I need to subtract the overlapping number. Alright. First of all, divisible by 3. Divisibility test of 3. That is, the sum of digits should be divisible by 3. Out of these 5, I need to choose 4 in order to make my number. Let me see what is the sum of them. Now here the sum is 15. That means whatever number that I leave, that has to be divisible by 3 because 15 is already divisible by 3. So that means only number that I can leave, that is 3. So if I have to make sure the number is divisible by 3, I have to choose the digits 1, 2, 4, and 5. Right? How many numbers can I have? How many 4-digit numbers where repetition is not allowed can I have? That is 4 digits. Right? Okay. Then numbers divisible by 5. Now divisibility test of 5. So that means either 0 will come or 5 will come. But here I do not have the option of 0. So that means 5 has to come. Right? Remaining 3 I need to choose from here. So I can choose that in 4, 3, 2. Right? Again, this is 24. Now the thing is, some numbers will be overlapping. Number divisible by 3 and number divisible by 5 will come in the overlapping case. So I need to talk about numbers which are divisible by 15 in short. But I will write it like this. Right? How many numbers would be there? Now first of all, I know the number is divisible by 5. So it has to be 5 over here. Number divisible by 3. That means out of these 4 digits, I have to arrange it over here. So 5 is already here. That means 3 numbers to be arranged in 3 places. That is 6 or 3 factorial. Right? So the answer is 24 plus 24 minus 6. Answer is 40. Alright, on to the next one. Now he says if all of these 4 points are consecutive, then write the value of A. Right? A is coming over here. And he says all these 4 points are consecutive. That means they lie on a single row. Right? So 2, minus 4 is here. Then we have minus 1, 5 is here. Then we have 3, 3. And the 4th point, that is 1, 8. I need to find the value of A. Right? Or A square, whatever. Now the thing is, if I know the equation of the circle, I know since this point lies on the circle, it will satisfy it. I will get the value of A. Right? So now my objective is to write the equation of the circle. I know 3 points. Right? If I need to write the equation of the circle, I need the center. Now obviously center will lie on the perpendicular bisector of this and on the perpendicular bisector of this. Wherever they meet, that will be the center. If I know the center, obviously I know the radius. That I can easily find out. If I want the center, write the equation of perpendicular bisector. You know what to do. You need to write the midpoint. So that will be what? 3 by 2, 1 by 2. No, this is 1 by 2. I'm sorry. Right? Then you need to write the midpoint of this. So this is 1, 1. Right? Then if I need to write the equation of this line, you know the point over here. You need the slope. You don't know the slope of this, you know the slope of this. You know the drill. So write the equation of perpendicular bisector. Perpendicular bisector, get the center. Right? Center will actually turn out to be equal to minus 1, 0. Such a nice answer. Right? Now choose any point. Suppose I have chosen 2, minus 4. Right? Radius is nothing but 5. So my equation of circle is x plus 1 whole square plus y square equal to 5 square. Now I know that 1, a lies on the circle, that means will satisfy. So instead of x, I'll put in 1. Instead of y, I will put in a, and I'll get the value of a square as 21. Alright, on to the next one. Now he says write number of solutions for this equation in this interval. In this interval, as in he says that x lies between minus pi by 2, 0. Now he says x belongs to this interval. Right? Now obviously in this equation, I have an absolute value. I will want to eventually remove it. So what I can do is I can talk about this 2x angle. So if x belongs to this interval, 2x belongs to this interval, minus pi to 0. Right? Now this 2x lies from minus pi to 0. So that means 2x belongs to either the fourth quadrant or the third quadrant. Right? Belongs to third quadrant or the fourth quadrant. Right? Mind it, here I have tangent 2x. If 2x belongs in the third quadrant, this is a positive quantity. If 2x belongs in the fourth quadrant, this is a negative quantity. So that means I know how to break this up. So I will take my 2x belonging to, first of all, third quadrant. So that means minus pi to minus pi. Right? This will open with a positive sign. So cos x divided by 1 plus positive, sin x equal to tangent 2x. Now cos and sin functions are there. Obviously I want to write it as sin 2x divided by cos 2x. Right? Cos x is here, sin 2x is here. Obviously I would want to write this as 2 sin x cos x. So the question is, you think I can cancel this and this? Mind it, my interval is this. But this is the interval for 2x, not x. So let me write my interval for x, which is minus pi by 2 to minus pi by 4. But still, in this interval also, cos x will not be equal to 0. So I can cancel this out. Cancel. And if I cross multiply, basically I'll get cos 2x equal to 2 sin square x plus 2 sin x. Now, if I had the equation in a single trigonometric function, I could have solved it. So obviously, I'll write cos 2x as 1 minus 2 sin square x. Now, this will be nothing but a quadratic in sin x, which I will solve using the quadratic formula. So sin x actually turns out to be minus 1 plus minus root 5 by 4. That's not a angle basically. But mind it, x belongs to this interval. Now, if x belongs to this one, I can see that the sin x will vary from minus 1 by root 2 to minus 1. So I should write it like this. Right? Obviously, one of the solution would be okay, as in minus 1 plus root 5 by 4 will work for me. No, minus 1 minus root 5 by 4 will work for me. Right? It will be here in between. So that means I'm getting one solution. Right? Let's move on to the, because third quadrant is done, let me move on to the fourth quadrant. So 2x belongs to now minus pi by 2 to 0. So let me write the interval for x also. So x belongs to minus pi by 4 to 0. Right? I have to do a kind of the same procedure only. So, but instead of plus over here, I will get minus. So I will get minus 2 sin square x minus 2 sin x equal to cos 2x, which I will write as 1 minus 2 sin square x. From here, I will again get one solution, sin x equal to minus 1 by 2, which I will get one solution in this interval. Right? So one from here. In total, I have two solutions, which is the answer. Alright, on to the next one. Now he says if A, B, C are mutually exclusive and exhaustive events of an experiment. Mutually exclusive. So that means no overlapping cases. And exhaustive. Between A, B, C, I have exhausted all the outcomes of the experiment. So that means if I add probability of A and probability of B and probability of C, this has to be equal to 1. Right? Now he says this relation is satisfied. And if this is equal to alpha, then find the value of this. Right? First of all, I need to make use of this relation. Twice of probability of A is equal to 5 times of probability of B is equal to 3 times of probability of C. trying to work out the relation between probability of A, probability of B, probability of C, let me just equate this. So because probability of A is nothing but K by 2 plus probability of B is nothing but K by 5 and probability of C is nothing but K by 3. You have the value of K from here, which turns out to be 30 by 31. Right? That means you're getting the answer. Probability of A, which was K by 2, which is 15 by 31. Right? Now this thing, he says B complements intersection C. So basically C minus B. Now C and B, they are mutually exclusive. Right? If these are mutually exclusive, that means this is nothing but C. So he says find this. So that is probability of C itself. Probability of C is K by 3. So this divided by 3, that is 10 by 31. Add the two, you'll get 25 by 31. Substitute it, you'll get the answer as 25. Alright, on to the next one. Now he says let K be the minimum value of this expression. Then you need to write the value of K minus 40. Basically the minimum value. Now, if you look at this expression carefully, that's a very nice observation over here. Because obviously I am not be multiplying each of these terms. Will take a little bit of time. Find it, 4 sin x over here, 4 sin x over here. Minus 15 over here, minus 15 over here. Right? Then minus 3 cos x plus 3 cos x. Can I see if I rewrite this? This is 4 sin x minus 15 minus cos x. And then 4 sin x minus 15 plus 3 cos x. Right? A minus 3, A plus 3. A square minus B square. So this is nothing but 4 sin x minus 15 whole square minus 3 cos x whole square. Right? If I open this up, obviously indirectly when I will get minus 9 into cos square x term, I will write that as 1 minus sin square x. I will try to change it into simple trigonometry. Right? And last expression that I get, that is 25 sin square x minus 120 sin x plus 260. Right? Now I am interested in the minimum value of this. Minimum value. I can see that the square can be completed. From here, if I say I complete the square, I get 5 sin x. And then from here, I will get, so 5 is getting involved from here, 2 is here. So I will write 12. Square completed. Plus 144 minus 144. So minus 144 plus 216, that is 72. Plus 72. Alright. So that means I am interested in the minimum value of this. Now this thing is easy. Sin x lies between minus 1 to 1. Right? Okay, I should write it like this. Then 5 multiplied, so I will not write that again. So minus 5 to 5. Minus 12, so that means minus 17. Minus 12, so minus 7. Right? Square obviously will lie between 0 to 289. No, I did not do minus. No, I did minus 12. Right? Cool. Now, careful. Minus 17 to minus 7. If I am squaring it up, so it will lie between 49 to 289. Alright. And then plus 72, so I will get plus 72 over here, so that is 121. This one I do not care actually. So I want the minimum value. Minimum value is 121 minus 40, the answer is 81. Alright, on to the next one. Now he says let U contain the elements 1, 2, 3, 4, 5, 6, 7, 10. Then he says P and Q are its subsets. Let K be the number of subsets P. So he is talking about subset P such that this condition is satisfied. Write first is square root of K. Basically, I need to find the number of subsets P which satisfy this condition. Right? Now, he says P minus Q union Q minus P is this set. P minus Q union Q minus P is this set. Right? Basically, I need to see where do these elements will go. 2, 6, 7. Where will it go? Here or here? Right? Let me consider that. First of all, I can put all of these elements over here. 2, 6, 7. Then this will get nothing. Right? Maybe I can shift 1 to this one. So 2, 6 over here, 7 over here. Right? Maybe I can shift 6 to that side. So I will get 2, 7 over here and 6 over here. Then maybe I can shift 2 to that side. So I am getting 6, 7 over here and 2 over here. Right? Now, 3 elements, 2 elements. That means I am leaving that case when 1 element can be there, right? So maybe 2 is here, that means 6, 7 will go here. 6 is here, 2, 7 will go here. Then 7 is here, 2, 6 will go here. So 3 element, 2 element, 1 element. Maybe I am putting nothing over here. So I will get 2, 6, 7 over here. So in total, I am getting these 8 cases, right? But this is with regard to this. I need to accommodate the remaining ones also. Remaining elements are which one? We have 1, which we need to put in. We have 3, then we have 4, then we have 5, and then we have 10. Right? We need to talk about these elements also. Now, let me make my Venn diagram to see where these elements can go. Right? So this is P, this is Q. Obviously, the big one is U. And we have P minus Q over here and Q minus P over here. This thing we have already studied. In how many ways can I fill these? I can see that. Now, the remaining elements, let me talk about 1. Right? I know 1 can either go outside here or 1 can go over here. It cannot go over here or here. You can see that. Right? So 1 has 2 possibilities. Right? Corresponding to that, let me talk about 3 now. Either 3 can go over here or here. Right? So that means again 2 possibilities. Corresponding to putting in the 1, I am putting in the 3. Right? That is why I will multiply. Cool. Now corresponding to this, I need to talk about 4. Either 4 will go over here or here. Again 2 possibilities. Then again 2 possibilities. Then again 2 possibilities. Right? That means number of ways of arranging these, that is 2 raised to power 5. Right? I am done with these elements. These elements can be arranged in how many ways? 8 ways. So 8 corresponding to this, I will arrange these. So that means multiplication. This is nothing but 256. Then he says write the positive square root of k, which is 16, which is the answer. With this, we have come to the end of discussion of paper 2. I have just discussed the main essential points of it. Calculation, I have left that up to you, that you need to do on your own. Thank you, and I will see you next time.